to 7.02. We're going to continue working on sketching normal curves and, of course, some of the things that we've been previously working on. Just a quick reminder, there is a quiz on Friday, so make sure that you put in some time and effort here to make sure that you're prepared for that. So here's just a quick review on what a normal distribution is and what a normal curve is and when we use it. The key thing to remember here is that we're not saying that data itself is normal, but when it appears to be it's symmetric and it's mound-shaped, we can approximately say it's normal, and so we can use a normal curve to approximate it. And using this, we're going to find that a normal curve allows us to say things about our data much more quickly than if we had to actually work with the data itself. Okay, so a salesman is keeping track of gas mileage for his car over 25 weeks. Here are the mileages. And of course, this is in miles per gallon, and it's rounded to the nearest whole number. And so there are some questions that just kind of naturally arise. The mean and standard deviation. Want you to compute this by hand. So you can use a calculator, obviously, to compute the deviations and then square them and so on and so forth. And if you need a reminder on how to compute that standard deviation, go back to 7.01. I promise you this will be the last time that you have to do it by hand, but it's important to understand where the standard deviation comes from so that you can talk about it in context. So go ahead and complete A through D here on your own, and we'll talk briefly about it when you're finished. All right, so I'm going to go ahead and skip to... All right, so hopefully in creating your histogram, your relative frequency histogram, you constructed something that looked sort of like this. And it looks as though our data is symmetric, it's mound-shaped, and so you can approximate it using a normal curve. Before we get to the normal curve and why it might make sense to approximate, let's take a look at some of the values. So the mean was 26, and the standard deviation was 1.5, which means that, and hopefully you wrote this, and if not, you want to go back and really make sure you understand this, that the average distance that a data point was away from the mean was 1.5. And that means that, if you averaged out the distance between all the samples that you got and 26 miles per gallon, well, on average, they were about 1.5 gallons off, right? So that is really helpful to know when you're thinking about data, right? It really tells you how spread out the data happens to be. And what we want to do now is think about how we could figure out the percentage of data points which are one standard deviation away from the mean, meaning either one standard deviation lower or one standard deviation higher. And so to do this, we will take a look at the ones that fall one below and the data points that fall one above. And we'll use our relative frequency histogram to do this, because think about what each bar represents, right? So this bar represents, well, it represents all of the data that was 25 miles per gallon, right? So that counts as 1 mile per gallon. And then the vertical distance tells me the frequency of that particular value, right? So all of the 25 mile per gallons, they take up 0.2 of my total, or 20%, right? So if we were to think about this as being just the area of this rectangle, what we're going to get is the total proportion that this rectangle represents, right? So this would be 1 mile per gallon times the 0.2 in the relative frequency, and what that will tell us is that this area is about 0.2, right? Or in other words, that this takes up 20% of my total distribution. We do the same thing for the next bar, right? This bar represents 1 mile per gallon, and its vertical distance is the frequency, and that's maybe 0.27. And so when we find the area of this gives us the total proportion of the 26 mile per gallon readings, which is 0.27 or 27%. We do the same thing for this bar here, right? This represents 1 mile per gallon, and the total vertical distance represents the frequency, and so that's going to give me, again, let's call that 0.2, it's going to give me an area of 0.2, or 20%, right? And so when I add these all up, I find that this whole piece here is going to be 0.67, or 67% of the data. Okay? And so now comes the time to think about why a normal curve is so useful here. Notice that we had to find the area of each of these bars here in order to find out how much data was in between our standard deviations. And finding the area of each of these bars can be kind of a pain. And with the normal curve, when we approximate using the normal curve, notice that the area taken up by these 3 bars is very close to the area taken up by the area under the curve between the standard deviations. So what I'm going to do is I'm actually just going to shade in the area under the curve, right? And notice that the area under the curve is, give or take, pretty much the same as the area underneath all 3 of the bars. Right? Notice that there are a couple pieces that the curve includes that are not included in the bars. So here is a little bit of the area that is included under the curve. Right? Those 2 red portions. But then also notice that with those pieces being included, there are some spaces that are excluded, right? So these 2 pieces don't quite make it, and these pieces up here don't quite make it. And so it seems like it's a pretty good approximation, right? The area underneath the curve is going to be, give or take, pretty much exactly the area underneath each of these bars. And so if I were to ask you what the area under the curve is, and we found this area here, it should be pretty darn close to 0.67, or 67%. And so the normal curve, it approximates the data, right? And we can use a normal curve to approximate data in this way. The area under the curve is going to be approximately the area underneath each of the histogram bars. Okay? And so this is kind of getting at why the normal curve is going to be so useful. Okay? So now we're going to go ahead and take a look at just a couple more examples to help get you feeling more comfortable with this stuff and get prepared for the quiz. So here are a few questions for you to answer. Fairly simple and straightforward, but to help you kind of expand your thinking and make sure you really are familiar with why the normal curve and normal distributions can be so helpful. So go ahead and pause the video now, answer these on your own, and we'll talk about it briefly at the end and then do one last question. All right. So hopefully that went well. Make sure that you have given some time to writing out both of the normal curves for these distributions and noticing how they're a little different. And number 4 will also be really important because on the quiz, that's going to be something that we're going to need to be able to do, right? Understand how it is that we find the standard deviation and why that makes sense from a real life perspective, right? It being the average distance away of the data points from the mean. Right, now let's get one last practice in with some real data. So this histogram below shows the distribution of heights to the nearest inch of 1,000 young women. Should be women. There you go. And here are just some basic questions about the histogram, and then we'll ask you some more complex ones to help you really get thinking about how the data is distributed. So go ahead and pause the video and work through each of these, and we will discuss them in class, but certainly doing them on your own is going to prepare you much better than anything else can for the quiz.